So archaeologists essentially adopt four main types of strategies when designing surveys to look for archaeological sites. The first are systematic surveys, and essentially what these are is we might take an area and divide it into a series of grids like this that essentially have here goes my lovely illustration tool, that series of equally spaced squares into an area, and what we would then do is essentially spend our time walking up and down these survey lines, looking on the ground to try and see if we can find any kinds of archaeological materials. Now we could also do this by aerial photography. We can send a plane over the area to take pictures of the ground. We can use satellite imagery. We could do a drone survey, which is a modern strategy of doing this. But ultimately we need to do some eventual ground truthing, which essentially just involves us actually walking and trying to see if we can find the objects of interest, be they stone tools or walls or some other kind of archaeological remain in these survey lines. And this kind of strategy is really useful if we're doing a survey in a small area and we want to know exactly and precisely how much of this area is comprised of archaeological material. And so we can then kind of cross squares off where we don't find any kinds of materials, and we can tick those in which we do, and by comparing them we can get a frequency of exactly how much archaeological material is in the area, and we can use these frequencies to then identify areas where we might want to excavate. So this might be a hotspot over here of archaeological finds that we might want to turn to when we dedicate more time and effort to setting up an excavation, which can be costly and require a lot of time. Now, that's one strategy. Another is to do a stratified random survey. So what we might do is take our area over here and assume that when humans occupy an area in prehistory, that they don't do it like they don't do it like a drone or a robot. They make decisions based on the kinds of factors that might compel them to occupy an area, such as the need for food or water, etc., and that those things are structured by the landscape features themselves. So there may be rivers that flow through the area, there could be mountain chains or some other kind of geographic features that structure some parts of the landscape. There might be grasslands in between. And so what we do is we essentially assume that humans have a probability of occupying some of the sites along rivers, some of the sites in grasslands, and some of the sites in mountains. And that we want to understand, relatively speaking, how much of these different parts of the landscape are actually occupied. And so in a stratified random survey, what we would do is take a feature like a river valley, as we have here with the Housatonic River Valley, and then along that pick a bunch of areas to go and look for archaeological materials. And so that's the random part of the strategy, is that we just sort of randomly select areas, but we use it, the stratified part of the survey sample is that we've taken the square and we've turned it into possible survey areas based on some kind of geographic feature. And so we would do that in the rivers, in the grasslands over here, and in the mountains. And we can then compare between these areas the frequency of archaeological sites that we've discovered, and then we can identify hotspots that we might want to return to go and actually do excavations in areas where we've found good promising sites to actually be surveyed. We could also then do a pure random survey, where we take, I'm running out of square space here, but let's say we take another square over here. This could be our hypothetical area, and we could assume that there is equal probability for archaeological sites to be found in any space in this landscape. And let's say we also don't have a lot of time to do this sort of long linear transect type systematic survey like we did in the first instance, and that perhaps the landscape isn't structured so neatly by rivers or mountains like we find in the second instance, but is fairly homogeneous. Let's say this is all a grassland environment. What we could then do in this instance is just simply randomly pick spots in the landscape at varying perhaps geographic coordinates. We could use a random number generator to get them, and we then visit each of these spots in turn to get an idea of whether or not there are any archaeological sites in the area. And this would be a strategy that we would use if we had some prior information about this kind of landscape in terms of how homogeneous it is, but also if we don't have a lot of time and resources and we just want to get a general sense of what's happening here and if there's any potential for excavations, and we can then return to one or two of these sites that show promise in terms of there being some kind of archaeological remains there. Now, that's how we would structure these sort of probabilistically, these different survey strategies. In other words, generate some kind of idea of the relative frequency of sites in different parts of the landscape. But we also need to take into account that surveys are also random, that they can be accidental, the discovery of archaeological sites. And in fact, accidents are a very typical way that archaeologists find sites. In the lecture today, I'll be giving you some examples of how some of the most famous rock art sites in Europe have been discovered by accident. Last week we talked about how volcanic, geological and tectonic activity in Eastern Africa has exposed fossil sites. It's kind of by accident that we found them in those areas. If it wasn't for these massive geological processes, they would not have been visible to fossil hunters. And me being situated in Falls Village, writing my PhD out in the woods and coming here for walks every day with my dog is how I found these sites here. And that's a random process. There was no sort of rhyme or reason to it. But now that I'm here and we can see the kinds of things that humans might congregate around, such as this river behind me and all the resources it provides, including fresh water, edible food like fish, the trees that comprise this forest over here provide another edible source of food, acorns, which are a staple for many Native American groups in North America. We now see that it actually makes sense that there are archaeological sites here. And there's one missing piece to the puzzle that I'll explain to you in a little bit when we get there, but there are also really good rocks for making tools, and that's a pretty important consideration for a lot of groups to make before settling into an area. And luckily enough, these sites along the Appalachian Trail have just those key ingredients for making this a perfect place to settle. So let's take a look and see what else we can find.